Welcome to chemistry classes. In this video, we are going to discuss about Unit 12, Grade 12 Chemistry, Unit 12, Aldehyde and Ketone. Aldehyde, ketone and carboxylic acid. Okay. So here in this chapter, we have to focus aldehyde, ketone, carboxylic acid. All these compounds contain carbon double bond oxygen. Carbon double bond oxygen. Okay, so we will say this functional group carbonyl compound, the compound which contain this type of functional group. Such type of compounds are called carbonyl compound. Okay, so here first we have to study here aldehyde and ketone. First, we have to discuss here nomenclature, naming of aldehyde and ketone. There are two type of naming, common name and IUPAC name. First, we have to discuss here common name of aldehyde and ketone. Okay, so here this is one aldehyde. So generally we know aldehyde, it contains carbon double bond oxygen single bond hydrogen. This is aldehyde. Shortly we can write it RCHO. This is aldehyde. Ketone means the compound which contain carbon oxygen double bond and both side alkyl group. Shortly we can write it like this, RCOR. So this is ketone and this is aldehyde. Okay, so here we have common name here CH3CHO. Here 2 carbon and aldehyde. This is acetaldehyde. Okay, and here benzene ring, top of benzene ring there is CHO. This is benzaldehyde, acetaldehyde. Okay, and here you can see here CH3 CHBr CH2 C double bond O hydrogen. This is aldehyde, and here to name this we had to give alpha, beta, gamma. This is functional group C double bond O hydrogen, and the next carbon, this is alpha carbon, beta carbon and gamma carbon. In beta carbon there is functional group bromo, Br, bromine. Okay, and here this is 4 carbon, so we have to say butanaldehyde, 4 carbon butanaldehyde, and on beta carbon there is bromine, so beta bromo butanaldehyde, okay, this is the name. So acetaldehyde, benzaldehyde, beta bromo butanaldehyde. Clear? And here these are ketone. Here 3 carbon. So here acetone, CH3CHO, acetaldehyde. We discuss here CH3CHO. This is acetaldehyde, and this is acetone. Acetone means CH3COCH3. Okay. So generally we will use common name for aldehyde and ketone. Okay, for other compound we know IUPAC name is very important. Here IUPAC and common name both are important for aldehyde and ketone. Okay, so here this is acetone, and here this is acetophenone. This part we will say here 1 carbon, so here acetophenone. Here 3 carbon. Okay, so propiophenone. Okay, this part we will say phenone. Here propiophenone. This is acetophenone. Here this is acetone. This is benzophenone. Okay, benzophenone, benzene ring. So benzophenone. So these are the general common name for aldehyde and ketone. Next one, we have to discuss here IUPAC name. Okay, second part IUPAC name. Here first one CH3 C double bond oxygen hydrogen. This is aldehyde with 2 carbon atom. So its name starts with eth, and this is aldehyde. The name of aldehyde end with al. ethanol, propanol, butanol. Okay, so this is aldehyde, and the name depends on the number of carbon atom, and the name of aldehyde end with Al. So ethanol. Okay, and here look here, C double bond oxygen hydrogen, this is aldehyde, and here 1 2 3 4 5 6 7 carbon atom. So here heptanol, hept, we know meth, eth, prop, but, pent, hex, hept. So heptanol. Okay, but here in third position there is CH3, methyl, and here fourth carbon there is bromo, functional group bromo and methyl. Bromo and methyl. Alphabetically we have to mention bromo first. So here 4 bromo, 3 methyl heptanol. This is the name of this compound. 4 bromo, 3 methyl heptanol. After 4 you have to put hyphen. Okay, also between 3 you have to put hyphen. Okay, so 4 bromo, 3 methyl heptanol. And here this is cyclic compound, and here 1 2 3 4 5 carbon. Okay, so it is cyclopentane. Actually it is cyclopentane, but here it is carbon double bond oxygen. It is aldehyde, here carbon double bond oxygen. Okay, so here it is 3 methyl cyclopentanol. Okay, 3 methyl cyclopentanol. Clear? And here this is aldehyde. Okay, and here cyclic compound with 6 carbon atom. So here cyclohexane carbaldehyde. This is the name of this compound, cyclohexane carbaldehyde. Again this is aldehyde, here 2 functional group, aldehyde and alkene. Okay, so here second carbon there is double bond, so totally 5 carbons, so pentanol, but here double bond, so pentanol. Okay, pentanol. But we have to mention the position of double bond in second carbon, so pent 2 enol. This is the name of this compound, pent 2 enol. And here this is ketone, and here 3 carbon. Okay, propanol, it is propanol, and we can give number 1 2 3. First carbon there is benzene, so 1 phenyl, propan 1 on. Okay, 1 phenyl, propan 1 on. It's mean ketone functional group in first carbon, 1 phenyl, propan 1 on. Okay, so here next one, this is not I told you before, this is aldehyde, this is not aldehyde, this is ketone. Here carbon double bond oxygen, each side there is carbon atom. This is ketone, not aldehyde. Okay, so here 1 2 3, third position there is CH3, 3 methyl cyclopentanone, because 1 2 3 4 5 carbon. Pentanone, not aldehyde, it is ketone, 3 methyl cyclopentanone. Okay, this is the name of this ketone. Next one, here this is also ketone. Okay, here 1 2 3 4 5 carbon. So here pentanone. Here 1 2 3, third position there is carbon double bond oxygen, so pent 3 on. Okay, but here second and fourth position there is CH3, so 2,4 dimethyl, pent 3 on. This is the name of this compound, 2,4 dimethyl pent 3 on. Okay, and here next one, look here, this compound there is 5 carbon atom. Okay, and aldehyde pentanol. But here third position there is ketone, C double bond oxygen. So we had to say 3 3-oxopentanal. Okay, we had to say 3-oxopentanal. Pentanal because 5 carbon and aldehyde, pentanal. Third position carbon double bond oxygen, 3-oxopentanal. Okay. Next one here, this is one compound which contains 3 aldehyde. 1 2 3 3 aldehyde functional group, and here 1 2 3 3 carbon atom. Okay, so here propane because 3 carbon propane, and here 1 2 3 in first second third carbon atom there is CH3, so pentane 1 2 3 tricarbaldehyde. Carbaldehyde, we will say this carbaldehyde. Okay, actually CHO here, carbon double bond oxygen single bond hydrogen, this is all same like this. Okay, aldehyde. So here propane 1 2 3 tricarbaldehyde, this is the name of this functional group. Okay, here next one, this is benzene. Here fourth position there is NO2, 4-nitrobenzaldehyde, 4-nitrobenzaldehyde, or we can say 4-nitrobenzene carbaldehyde, 4-nitrobenzene carbaldehyde. This we will say carbaldehyde. Okay, so 4-nitrobenzene carbaldehyde. So you can name aldehyde and ketone this way. Okay, you can check textbook and practice more question related to this. Okay, practice more how to name common name and UPSC name for aldehyde and ketone. Okay, next one we have to discuss here structure of carbonyl group. Structure of carbonyl group. We know carbonyl group mean carbon double bond oxygen. Okay, and here this carbonyl group which contain 3 sigma bond. Okay, 3 sigma bond and 1 pi bond. Also in carbonyl group oxygen contain 2 lone pair electron. Okay, so here carbonyl group mean it contain 3 sigma bond and 1 pi bond, and here this oxygen atom contain 2 lone pair electron, and these 2 lone pair electrons are one above and one below the plane. Okay, and rest of the atoms are in same plane, but this electron pair present in the oxygen, one is above the plane and another one below the plane. Clear? And the bond angle here, all this bond angle is 120 degree. Okay, here this bond angle, this bond angle, this bond angle, all bond angle 120 degree. Clear? So these are the points we have to understand here. Carbonyl group, this carbonyl group contain 3 sigma bond and 1 pi bond. Okay, and here 2 lone pair electron, one above the plane and another one below the plane. Clear? And the bond angle is 120 degree. Okay, and also in carbonyl group we know oxygen is highly electronegative, and it pull electron pair towards itself, and here oxygen getting a partial negative charge and carbon getting a partial positive charge. That means carbon act as a electrophile and oxygen act as nucleophile. So in carbonyl group oxygen is highly electronegative atom, it pull electron pair towards itself, and oxygen getting a partial negative charge and carbon getting a partial positive charge. Clear? That's why here carbon getting positive charge, so carbon act as electrophile and oxygen act as nucleophile. Clear? Next one we have to discuss here preparation of aldehyde and ketone. First we will discuss here preparation of aldehyde. Preparation of aldehyde, first one from acyl chloride. Acyl chloride or acid chloride. We know carboxylic acid mean carbon double bond oxygen single bond OH. Okay, instead of OH here carbon double bond oxygen single bond Cl. This type of compounds are called acyl chloride. Acyl chloride or acid chloride. Okay, so here we have benzoyl chloride. Benzoyl chloride after reduction in presence of palladium and barium sulfate, it will change to benzaldehyde. Okay, so here preparation of aldehyde first from acyl chloride. Here we can change benzoyl chloride to benzaldehyde. Benzoyl chloride after reduction in presence of palladium and barium sulfate. Okay, a mixture of palladium and barium sulfate, we will reduce benzoyl chloride. Benzoyl chloride will change to benzaldehyde. We know benzaldehyde means benzene ring. On the top of benzene ring there will be aldehyde. Okay, such type of aldehyde we can produce. Okay, and this type of chemical reactions are called, this type of reduction called Rosenmund reduction. Rosenmund reduction means benzoyl chloride in presence of palladium and barium sulfate. After reduction it will change to benzaldehyde. This reduction called Rosenmund reduction. Clear? So here we discuss preparation of aldehyde from acid chloride. Next one we have to discuss here preparation of aldehyde from nitriles. Nitriles mean we know the compound which contains CN or CN, C triple bond N. This type of functional group called nitriles. Okay, so this type of nitriles we can change to aldehyde. So here nitriles and ester. Next one, second one, preparation of aldehyde from nitriles and ester. Nitriles mean compound which contain CN, that is nitrile. Okay, so here this type of nitriles reacting with SnCl2 and HCl, and it will change to a compound which contain carbon double bond nitrogen. This type of compounds are called imine. Okay, so here look here nitriles after treating with SnCl2 and HCl we will obtain imine. Imine mean imine mean RCH double bond NH2. This imine after hydrolysis we can change it aldehyde. Okay, so here we discussed how to convert nitriles to aldehyde. Nitriles treating with SnCl2 and HCl we can change it imine after hydrolysis. H3O plus mean same like H plus. Okay, acidic hydrolysis. After hydrolysis of imine it will change to aldehyde. Okay, and NH3 or ammonium compound will be side product. Okay, so this type of chemical reaction, this is also reduction. This reduction is called Stephen reaction. Okay, this chemical reaction is called Stephen reaction. The previous one Rosenmund reduction means benzoyl chloride after treating with palladium and barium sulfate it will change to benzaldehyde. So you have to remember Rosenmund reduction. So you have to remember palladium and barium sulfate. That is Rosenmund reduction. Stephen reaction, you have to remember SnCl2 and HCl. Stephen reaction, the reagent used SnCl2 and HCl. Rosenmund reaction, the reagent used here palladium and barium sulfate, or condition for this chemical reaction palladium and barium sulfate. Okay, so here we discuss Stephen reaction. Stephen reaction mean here nitriles after treating with SnCl2 and HCl imine formed. Imine after hydrolysis it changed to aldehyde. Okay, so here this is Stephen reaction. Okay, Stephen reaction means this chemical reaction takes place in presence of SnCl2 and HCl. Okay, instead of SnCl2 and HCl we can use another reagent, it is diisobutyl aluminum hydride. Diisobutyl aluminium hydride, DIAH, diisobutyl aluminum hydride. Okay, so in presence of diisobutyl aluminum hydride, nitriles change to imine after hydrolysis it will change to aldehyde. Clear? So here it is nitriles. Okay, instead of SnCl2 and HCl we can use, this is the reducing agent, instead of this we can use this reagent diisobutyl aluminum hydride, nitriles change to imine further hydrolysis it will change to aldehyde. Okay, so this we can change nitriles to aldehyde two way. First one SnCl2 and HCl, that chemical reaction is Stephen reaction. Also we can use diisobutyl aluminum hydride. Also nitriles will change to aldehyde in presence of this reagent. Clear? So here we discuss nitriles. Okay, nitriles in presence of diisobutyl aluminum hydride, it will change to imine, then imine change to aldehyde. First nitrile to imine to aldehyde. Here reagent diisobutyl aluminum hydride. Okay, and here same chemical reaction happening in presence of tin chloride and HCl. This chemical reaction is called Stephen reaction. Clear? See here one example for such type of chemical reaction. Here this compound is nitrile. Here this is nitrile, CN. Also here alkene functional group, alkene. So this compound in presence of diisobutyl aluminum hydride, here CN will change to aldehyde. Here alkene functional group no change. Okay, so this compound which contain carbon-carbon double bond, also it is nitrile. Okay, so in presence of diisobutyl aluminum hydride, this part no change. Nitrile it will change to aldehyde. Okay, reaction with isobutyl aluminum hydride followed by hydrolysis, it will change to aldehyde. Clear? Next one we have to discuss here, same reagent diisobutyl aluminum hydride, it helps to convert ester to aldehyde. We can convert ester to aldehyde in presence of diisobutyl aluminum hydride. We know this is ester linkage. Okay, this is after hydrolysis in presence of diisobutyl aluminum hydride, it will change to aldehyde. Okay, so this part will change to aldehyde, CH3 CH2 9 CH2 9 times CHO. Okay, so this is aldehyde. So you understand here diisobutyl aluminum hydride, it helps to convert nitriles and ester to aldehyde. Okay, nitriles in presence of tin and HCl, tin chloride and HCl, it will change to aldehyde. This chemical reaction is called Stephen reaction. So during Stephen reaction, imine is intermediate product. Imine is intermediate product during Stephen chemical reaction. Clear? Next one, preparation of aldehyde. Next one, from hydrocarbon. So here we discuss how to convert nitriles to aldehyde, ester to aldehyde. This type of chemical reaction already we discussed. Next one, we have to discuss how to convert hydrocarbon. Okay, out of hydrocarbon there are different category. Okay, so here first one, here oxidation of methyl benzene. Hydrocarbon we can change to aldehyde. First one, how to convert methyl benzene. This is methyl benzene. We can convert methyl benzene to aldehyde. We can convert methyl benzene to aldehyde different method. Okay, so here conversion of methyl benzene to aldehyde, benzaldehyde. First one, using chromyl chloride. This is chromyl chloride, CrO2Cl2, chromyl chloride. Okay, so we have two reagent. One is chromyl chromyl chloride means CrO2Cl2, and another one chromic oxide. Chromyl chloride means CrO2Cl2. Chromic oxide CrO3. Chromic oxide means CrO3. That is chromic oxide, chromyl chloride. So here benzaldehyde in presence of carbon disulfide and chromic chloride, it will be a chromium complex. First it will change to chromium complex. This chromium complex, further hydrolysis, it will change to benzaldehyde. Okay, so here methyl benzene treating with chromyl chloride in presence of carbon disulfide, it will change to a chromium complex. Okay, so look here benzene ring, and here CH, same here CH3, here it is CH, and here look here CrO2Cl2, here OCrOHCl2, CrO2Cl2. Similarly here CrOHCl2. Okay, so compare to this and this, here one hydrogen is here. Okay, this twice, that is chromium complex. This chromium complex, further hydrolysis, it will change to benzaldehyde, and this chemical reaction is called Aldehyde reaction. This chemical reaction is called Aldehyde reaction. So Aldehyde reaction mean here methyl benzene treated with chromyl chloride. Okay, benzaldehyde treated with chromyl chloride in presence of carbon disulfide, it will change to benzaldehyde. Okay, methyl benzene changed to benzaldehyde in presence of carbon disulfide and chromyl chloride. This chemical reaction is called Aldehyde reaction. This is Aldehyde reaction. Okay, so I told you in the beginning, first one we have to use chromyl chloride, next one chromic oxide. Chromyl chloride means CrO2Cl2, that is chromyl chloride. Chromic oxide means CrO3, chromic oxide. Okay, so here methyl benzene treating with chromic oxide in presence of acetic anhydride. This is acetic anhydride. Okay, so methyl benzene treated with chromic oxide in presence of acetic anhydride, it will change to a complex. This complex, after hydrolysis, it will change to benzaldehyde. Okay, so this type of chemical reaction, first you have to explain in the words. Okay, then after you have to write in the equation. Okay, so always in organic chemistry you have to write, you have to explain the words, then after that you have to show the structure. Clear? So here chromic oxide mean here benzaldehyde treated with chromic oxide and acetic anhydride. Okay, we know acetic anhydride means CH3, C double bond oxygen, C double bond oxygen, CH3. This is acetic anhydride. Here, look here, this is repeating 2 times. So we can write it CH3CO. This is CH3CO twice oxygen. This is acetic anhydride. Acetic anhydride means carboxylic acid after dehydration it forms acetic anhydride. That is acetic anhydride. So here methyl benzene treating with chromic oxide. Okay, methyl benzene treated with chromic oxide in presence of acetic anhydride, it will change to a complex. This complex, further hydrolysis, it will change to benzaldehyde. Okay, so here this complex mean here, look here, benzene ring, then CH3, benzene ring, here CH. Okay, same like this, here it was CH3, now here CH. So this part here and here it is same. Here acetic anhydride, so here COCH3, COCH3 twice. Okay, so that is complex formed here. This complex is called benzaldehyde anhydride, benzaldehyde anhydride. Okay, here this complex is chromium complex, here benzaldehyde anhydride. Both complex after hydrolysis it will be benzaldehyde. So which one is Aldehyde reaction? Methyl benzene treated with chromyl chloride in presence of carbon disulfide, that is Ettard reaction. Here no specific name for this chemical reaction. Here you understand methyl benzene treated with chromic oxide in presence of acetic anhydride. Also benzaldehyde will be the product. Clear? So here we discussed preparation of benzaldehyde from methyl benzene. After oxidation of methyl benzene, we can produce benzaldehyde. Okay, using chromyl chloride, using chromic oxide, we can convert methyl benzene to benzaldehyde. Next one, we have to discuss here conversion of methyl benzene to benzaldehyde by side chain reaction. By side chain reaction. So look here methyl benzene treated with chlorine in presence of sunlight. Here this side chain of benzaldehyde, here CH3, it is side chain. It will react with Cl2 and form CHCl2. This is benzyl chloride. This benzyl chloride, after hydrolysis at a higher temperature, it will change to benzaldehyde. Okay, so this is another method of preparation of benzaldehyde. Okay, side chain reaction. Methyl benzene treated with chlorine in presence of sunlight, benzyl chloride will be formed. This is structure of benzyl chloride, C6H5. You can write it like this, C6H5CHCl2. Okay, this CHCl2 like side chain. This is benzyl chloride. Benzyl chloride after hydrolysis at higher temperature, it will change to benzaldehyde. Clear? Here last method of preparation of benzaldehyde, Gattermann-Koch reaction. Gattermann-Koch reaction mean benzene treated with carbon monoxide and HCl. Carbon monoxide and HCl in presence of anhydrous aluminium chloride and cuprous chloride. Okay, it will change to benzaldehyde. This chemical reaction is called Gattermann-Koch reaction. Okay, methyl benzene treating with carbon monoxide and HCl in presence of anhydrous aluminium chloride and cuprous chloride, cuprous chloride. So methyl benzene will change to benzaldehyde. This chemical reaction is called Gattermann reaction, and the previous one, methyl benzene treated with chlorine in presence of sunlight, benzyl chloride will be formed. This benzyl chloride after hydrolysis at higher temperature, it will be benzaldehyde. So these are the methods to prepare aldehyde. Okay, so all these things we discuss aromatic aldehyde, preparation of aromatic aldehyde. Okay, and the preparation of aliphatic aldehyde already we discussed in +1 classes. Okay, oxidation of alcohol, primary alcohol after oxidation it will be aldehyde, secondary alcohol after oxidation it will be ketone. This type of chemical reactions already we discussed in +1 textbook. You can revise these things. Clear? Next one, we have to discuss here preparation of ketone. Okay, so here preparation of ketone, first one from acyl chloride or acid chloride. Acid chloride or acyl chloride reacted with dialkyl cadmium. Here it is CD. Okay, dialkyl cadmium. CD mean cadmium. So here acyl chloride reacted with dialkyl cadmium. Here look here, RC double bond oxygen. Okay, and then this R will join over here, then it will be ketone, carbon double bond oxygen, each side there will be alkyl group. This is ketone. So here first preparation of ketone here. Here acyl chloride reacted with dialkyl cadmium. Dialkyl cadmium means R2CD. We can prepare dialkyl cadmium by this chemical reaction. Grignard reagent. We know Grignard reagent mean RMgX. RMgX. This is Grignard reagent. RMgX treated with cadmium chloride CdCl2. It will be dialkyl cadmium. Okay. So here Grignard reagent treated with cadmium chloride dialkyl. Here it should be 2 molecule. Okay, then only here it will be R2. We need R2. So we need here 2 molecules of Grignard reagent. It will react with cadmium chloride. We will obtain dialkyl cadmium and this side product. Okay, so this dialkyl cadmium treated with acyl chloride, we will obtain ketone. This is one of the method of preparation of ketone. Second method of preparation of ketone from nitrile. RCN, that is nitrile. We already discussed nitrile compound. Nitrile compound reacted with Grignard reagent. Again Grignard reagent RMgX. This is aromatic. This is benzene ring. Okay, C6H5 MgBr. Also this is Grignard reagent. Okay, here R is C6H5. So here CH3 CH2 CN, this is nitrile. Okay, and here this is positive charge and this is negative charge. Okay, and here MgBr will be attack. MgBr will be bond with nitrogen and C6H5 will bond with carbon atom, and this triple bond will change to double bond. Look here, here same thing here, CH3 CH2 carbon. Okay, CH3 CH2 carbon, this triple bond changes to double bond, and here NMgBr, MgBr bond with the nitrogen, NMgBr, and C6H5 will bond with the carbon atom, and this intermediate product formed. This product further hydrolysis, it will change to aldehyde. Okay, this bond, this part will be break, and here oxygen will be coming. So look here, CH3 CH2C, NMgBr removed. Instead of NMgBr, here oxygen, C6H5. So this is ketone. Okay, so here from nitrile we can convert ketone. Nitrile treated with the C6H5 MgBr, this triple bond change to double bond, C6H5 will bond with carbon, NMgBr. After hydrolysis, NMgBr will be removed, and this part will be NMgBr will be removed, and there will be carbon double bond oxygen, that is ketone. Okay, here we discuss acyl chloride reacted with dialkyl cadmium, it will be ketone. Clear? Okay, so here last method of preparation of ketone, again from acyl chloride. Acyl chloride reacted with benzene. Okay, here aromatic or aliphatic acyl chloride reacted with benzene, we will obtain ketone, and this chemical reaction takes place in presence of anhydrous aluminum chloride, Lewis acid, anhydrous aluminum chloride. Okay, so here we discussed 3 methods of preparation of ketone. First one, acyl chloride treated with dialkyl cadmium. And the second method, nitriles CN, nitriles reacted with the C6H5 MgBr. Okay, third one, acyl chloride treated with benzene, acyl chloride treated with benzene, aliphatic or aromatic acyl chloride treated with benzene in presence of anhydrous aluminum chloride, we will obtain ketone. Example for this type of compound, here benzene treated with, I choose here CH3COCl. Okay, also you can choose any type of acyl chloride, C double bond oxygen Cl. Okay, so these two, after chemical reaction you will obtain C6H5, C double bond oxygen, C6H5. So here benzene ring, okay, C double bond oxygen, Okay, benzophenone, we will obtain benzophenone. And here benzene treated with acyl chloride, acid chloride, we will obtain this type of ketone, acetophenone. Okay, so these are the different chemical reactions, these are the different methods to prepare aldehyde and ketone. Okay, so also there are some other methods. After oxidation of secondary alcohol, we will obtain ketone. This type of chemical reaction already we discussed in +1 textbook. You can revise that textbook. Okay, so these are the things we have to discuss in this video. Rest of the things we will discuss next class. Okay, so thank you for watching this channel.